Hello, everybody. A very good afternoon. Dear authors and invited guests, welcome to Technical Session 8D. Myself, Sirali Gaur, and today's session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development, ICT4SD 2026, Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today, 10th of July 2026, Goa, India. The virtual event is being held through Zoom from 9 to 11th July 2026. I hope you will enjoy this knowledgeable and interactive session through the day. In this session, we have a total of 10 presentations. Each presenter will be given 10 minutes for their presentation, 2 minutes for question and answers, and on the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or any update, please feel free to write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session today, Dr. Disha S. Wankhede. Dr. Disha is an assistant professor at Vishwakarma Institute of Technology, Pune, India. She has 17 plus years of teaching experience. Her skills and expertise lie in machine learning, computer vision, artificial intelligence. Her research areas include deep learning and image processing in healthcare and agriculture domain. I welcome you, ma'am, and please share a few words with us today.
Yeah, good afternoon. Thank you for the short and sweet introduction. Yes, I am working as a assistant professor in VIT College of Engineering today. I'm glad to here, and I'm happy to see that what type of new research comes you are presenting. Okay, the paper. So best of luck for your paper presentation. And yes, please start.
Thank you so much, ma'am. So, to begin with the presentations, first we have Jayashree Patil with the paper title Advances in Liver Fibrosis Staging in NAFLD, a multimodal perspective on biomarkers, imaging, and artificial intelligence. Dear presenter, you may start presenting.
Ma'am, I can't share my screen. Right.
Yes, ma'am, you can start now.
My presentation is visible.
Yes, ma'am.
Good afternoon, everyone. I'm Jayashree Patil. I'm going to present my paper. ID is 1365, and my paper title is Advances in Liver Fibrosis Staging in NFLD, a multimodal perspective on biomarkers, imaging, and artificial intelligence. So, agenda of this presentation is I'm going to present my abstract, what I have done, then introduction,
Dear
liver disease.
presenter,
Yes.
I'm sorry to interrupt, but your voice is not very clear.
Okay, just a minute, ma'am.
Okay.
Am I audible now, ma'am?
It's still a little bit unclear.
Hello. Am I audible now?
Yes, ma'am.
Yeah. Then I'm going to explain about the liver disease progression pathways, and then as this is my survey paper, so I'm going to present the liver conditions and the disease manifestation. Then what is the need for a non-invasive diagnostic methods? and diagnostic modalities used in a literature for a liver disease prediction, and some artificial intelligence techniques for liver disease diagnosis, and also what are the challenges and the future research direction that I'm going to discuss. So first of all, we will see what is NFLD. So this is non-alcoholic fatty liver disease. So it is a condition of a liver in which excess fat builds up in the liver of a people who drink little or no alcohol. That's why it is called as a non-alcoholic fatty liver disease. Uh, because in fatty liver disease, there is a explicit reason of drinking the alcohol, but in uh, patients which do not have a alcohol intake, they can also have a fatty liver, and that's why it is named as a non-alcoholic fatty liver disease. So it is one of the most common liver disease worldwide and closely linked to some uh, some conditions like obesity, type 2 diabetes, high cholesterol or high triglyceride, high blood pressure, and insulin resistance and metabolic syndrome. So in my paper, I conducted the systematic survey of existing work concerning the NFLD diagnostics in three perspectives. One is a types of a diagnostic tools. Second one is a liver characteristics which are considered for a prediction of a liver disease in a early stages. And third one is a techniques in a AI in the liver disease. So this is the liver disease progression pathway. So generally, this diagram shows that a healthy liver, then if it is fatty liver, then when fatty liver, fat accumulates in liver, it is known as a steatosis or a fatty liver. Then NASH is a condition of a liver where fat causes the inflammation and the liver cell damages. After the NASH, next stage comes as a fibrosis, where scar tissue develop in the liver, and at the end, it is called as a cirrhosis, and then it is a liver cancer. It converts into the liver cancer. So these are the different stages of a liver disease, which may progress or may not progress. So there are some liver disease diagnostic methods are used from many years. That is, invasive diagnostic techniques are there, and also non-invasive diagnostic techniques are there. So invasive diagnostic techniques include the liver biopsy, which is the gold standard, where part of a liver is taken out, and that is checked in a laboratory. But as it is invasive means here patient has to undergo operatives, and then we can take the part of a liver biopsy. Similarly, histopathological staining, histopathological image analysis, tissue-based molecular and genetic analysis. These are the invasive methods. And non-invasive method includes the clinical assessment, laboratory test, serum biomarker scores, imaging modalities, AI-based diagnosis, emerging imaging, and liquid biopsy technologies. So out of these two diagnostic methods, so actually non-invasive diagnostic method is most suitable or most important, because there are some limitations of a liver biopsy. But even though it is a gold standard, it is invasive, it requires a surgical procedure. Then there might be sampling errors. Then there might be different opinions of a pathologist. It complications like bleeding, infection, pains, and it is also expensive, so it is not affordable to every patient. That's why we need to have such a diagnostic tools, and mostly it might be, if it is AI powered non-invasive diagnostic tools, it will be helpful to patients as well as practitioners to diagnose the stage of liver disease earlier. So these are the diagnostic methods used, like a serum biomarkers, medical imaging like CT, MRI, ultrasound imaging, then digital pathology and multimodal approaches are also can be considered under the non-invasive diagnostic methods. So when we integrate the AI into these earlier non-invasive diagnostic methods, it becomes easy for practitioners to detect the early stages. So in a survey, whatever number of research papers I studied in this under this study, so where I found there are different liver conditions and the disease which is manifested. So just like a steatosis, then NASH is there, non-alcoholic steatohepatitis, then fibrosis, then NFLD inflammation, portal hypertension, iron overload, and the HCC, that is hepatocellular carcinoma. So these are the different type of liver conditions which are considered in a literature, and most of this fibrosis is studied by number of authors. You can see by the references given here, fibrosis mostly studied in a literature. So these are the diagnostic from this literature. I found that these are the different diagnostic modalities used for AI-based techniques like a serum biomarkers, which has a key advantage of a non-invasive and the cost-effective, where clinical data and some blood parameters are taken for a consideration, which comes in a text format. Then ultrasound imaging also used in a literature along with the AI techniques, which is widely available and there is no harm of the radiations. Then computer tomography, that is CT images, where these are images are high resolution images and the fast we can um, predict the fast. Then MRI images also, it consists of excellent soft tissue contrast images. Then digital pathology, histology, which is gold standard and detailed. It gives a detailed analysis and multiple modalities. So here, and also electronic health record, that is which is real world data is integrated along with the living standard of patients with some their habits of living. So such type of electronic health record, which consists of clinical data as well as their daily routines, that can be also used for predicting the liver disease. So in literature, I found these AI techniques used right from a traditional machine learning techniques up to optimization algorithms. So these different AI techniques are used in a literature for predicting the or for solving the different types of liver disease problems. So traditional machine learning algorithms like SVM, random forest, logistic regression, KNN, XGBoost, Lasso, these are used for solving the liver disease problem. Like in deep learning, CNN, transformer networks, transfer learning, and deep learning radiomics. These are used to solve the problems. Then after deep learning, few papers have used the ensemble methods where different deep learning models are used as an ensemble, and different techniques like a bagging and boosting, where bagging is similar to a random forest and boosting also used, and stacking, multi-stacking, and along with optimization is used. Few papers has shown that they have used the classical image analysis like a feature extraction, color deconvolution, CPA, LSN, SHGS, etc. And only selective paper, one or two, which use the optimization algorithms along with the different models. That is the optimization technique used is the energy valley optimization. So these are the classical image analysis technique. Hello.
I'm sorry to interrupt, but you have crossed the 9-minute limit. Can you please conclude your presentation soon?
Okay. Soon I will do that. So these are the classical image techniques like a feature extraction, then color deconvolution, collagen proportionate area, liver surface nodularity, and second harmonic generation microscopy. So such type of classical image techniques are used. Then in mostly used or recent techniques used for liver disease prediction or staging, this ensemble method, and which consists of bagging, boosting, and the stacking. So bagging indicates that different models are used and they work in a parallel, and their result is averaged by using different methods like a plotting, and then output is concluded. In case of boosting, there are different models works, but they works in a sequence, and at the end final model we get. And in a stacking, there are different layers of a you can say ensemble, and different models are used as a base learners, and that base learners output is given to some logistic regression, or you can say meta learner, along with the optimization algorithm, and that predicts the output. So from that literature, I found that stacking and the EV optimization is the best one, which gives the AUC of 0.94. So from this survey paper, I found that these are some future directions, hybrid model. So only few papers have used the hybrid and which has a limitations of a data set. Hybrid in the sense image data as well as a clinical data is not used. Balanced you can say computational cost is also required. Modeling, making a hybrid of a different models. Then multimodal data integration is important. Also explainable AI and reduce the data dependency and standardization is required because many data sets are available in only one modality, either image or a clinical data. So such a type of data set is required that is which consists of image as well as a clinical so that we can work for a better accuracy and for a better clinical prediction. We can use the explainable AIs. Thank you.
Thank you so much for that presentation. Do we have any questions?
Yeah, Jayashree, I have one question. So that how does your model compare with the existing clinical scoring or clinical score or a hospital score system with the Enfield fibrosis score? Have you compared with the existing score with the any hospitals data?
No, ma'am. No, ma'am. Right now,
Okay.
I'm working on an implementation of my proposed model. It was a survey done before selecting my proposed methodology.
Have you got the data set from any of the hospital or have connected with any of the
Yes, ma'am.
hospital?
Right now, I'm collecting from my hospital in my city.
Mm-hmm.
I'm collecting that both multimodal data, image data, and the clinical data.
Okay. Okay.
For
Okay.
patients, time series data I'm collecting because I'm going to predict the progression of a NFLD to NASH, and for that,
Mm-hmm.
I require data of a patient of a multiple visits, and that
Yeah.
I'm right now collecting, ma'am. That.
Okay. So just now you have done your survey part only, right?
Yes, ma'am. Yes.
Okay. Okay. Got it.
Thank you so much for the presentation.
Thank you, ma'am. Thank you, everyone.
You can stop presenting now.
I stopped my sharing. Still, it is visible.
Yeah,
Okay. Now,
yeah, thank you. Next, we have Jayendra P. Rane with the paper title AI-assisted lip sync analysis in sync sound versus dubbing for fiction film production, an experimental study. Dear presenter, you may start presenting.
Am I audible?
Yes.
Okay. Let me just share the screen. Is it?
Yes, sir, it's visible now.
Okay. Just. Hello. So I'm Jayendra Rane from IMD University, Rajasthan. And this our paper titled as AI-assisted lip sync analysis and sync sound versus the dubbing for fiction film production. As this is an experimental study. Along with me, the authors are Dr. Prashant Kamal, Dr. Akanksha Katuria from IMD University, Jaipur, and Dr. Samram Patnaik from IMD University, Dubai, UAE. Our paper ID is 1558. So, sound actually plays the vital role in cinematic storytelling. We all knows about that, significantly shaping the how audience connect with the film, how they experience the emotions through the audio also simultaneously and video also. They understood the narrative through that both the ways. In fiction filmmaking, two primary methods are used actually in the industry standard to capture the dollar. One is sync sound, and other one is dubbing sound. I'll explain that in further PPT. It is also known as automated dialogue replacement (ADR) in a short form, technical word. This research project seeks to conduct an experimental evaluation of how synchronized sound compares to dubbing and influencing several important audience perceptions variables and all these things. The key areas focuses will include the sense of realism. Will explain that what realism is all about, viewers experience, the level of engagement with the content of audience, clarity of dialogue and sound and visual simultaneously, authenticity of performances based on that connectivity. Why we choose that, or what is the motivation behind this experiment? Sound shapes, as we discussed, audience perception, narrative realism, and technical authenticity. Choices between whether I should go for this particular scene with sync sound or ADR, often guided by the preferences rather than empirical evidences. We choose that. Why we need to go for sync or ADR itself. Need to evaluate the how acoustic environment affects AI assisted lip syncs. AI assisted lip syncs are actually used in uh, Premiere Pro, that is editing software from Adobe. Audience perception metrics. Now we need to understand what is dubbing and what is the importance of dubbing. Dubbing is the primary importance of dubbing is especially automated dialogue replacement (ADR) lies in absolute control powers. It provides over the acoustic treatment where the other noise is not there. That control has in the ADR. Beyond the technical clarity, dubbing offers unique layer of creative flexibility during the post-production. On-set performances can be hindered by the physical constraint like wind and all these things, traffic noise and all these things. But studio dubbing will provide you that soundproof things. Look at the chart, you can understand the table, you can understand first is features, second is sync sound, and third is studio dubbing. So in ambient sound, sync sound, traffic, wind, as I said, room tone is clearly audible, but in dubbing, nearly zero soundproof noise is there. Acoustic reflection, uncontrolled, it is in uncontrolled, and it is completely controlled or diffused. We can diffuse that or absorb that. Microphone here used is a boom mic, shotgun mic, and here we use the large diaphragm condenser. Signal to noise ratio, generally we consider this SNR, that is lower in sync sound and consistently higher level in his dubbing sound. AI compatibility challenging, it challenges somehow because of the wind and traffic for the sync sound, outdoor sounds. And the second one, studio dubbing, it's absolutely ideal. Very high fidelity is provided over there. Now, the research objective to compare the perceived realism of this for sync sound versus dubbing to measure the emotional engagement differences, to assess the dialogue clarity and intelligibility, and to analyze the perceived acting authenticity provided by that audio also. Do the audience feel that same way? Now, what is exactly the experiment we have done? It is in a three phases actually. A phase one is outdoor, fully uncontrolled situation. Phase two, indoor with semi-controlled situation, and phase three is a studio dubbing, fully controlled situation. We did uh, a shoot where the same short fictional scene has been produced in three different phases, three audio conditions, all the variables held constant. Quantitative audience measurement and AIP2V metrics has been done. Now see this, if you can see these visuals. First phase is here. You can see this is completely outdoor situation. This one is a phase two, semi controlled situation, but the boom mic is there. And the third one here, you can't see the boom mic, and it is completely short uh, at one point, and later on it is recorded or dubbed again back after the once it is shot been recovered. The recording and technical standards we used, that is industry standards, that 32 beat float, 48 kilohertz minimum it required. We use that uncompressed BWF WAV is the audio extension file extension. Gain staging is between the 12 to minus 6 decibels for the audio. Hyper quadrant boom mic has been used. The second lavalier or lapel mic has been used, and the third one for the large, as I earlier said, diaphragm condenser mic is been used for that. On-site workflow and data management, pre-production, location consistency, noise floor, RT is a reverb time 60. Microphone placement is boom mic, as I earlier or already said. That differs in three different ways. On-set practices, slate, time code. We generally see that while shooting any film or something like that, we have seen multiple times that slate is there, short one, take one, and all this kind of things. That is called slate and time code jam sync. Room tone capture, multi-track recording is being used. Metadata tagging is used for the scenes and take we have taken. To manage that data entirely, we use that AI alignment. For that, post-production and signal enhancement, spectral repair and denoising process has been used. Reverbing has been used. Equalization for the equalizer through the equalizer, focused between 3 to 7 kilohertz has been used. Loudness normalization has been used to 23 LUFs minus 23 LF. So ITUR BS 0.1770/4 compliance. Phase aware foley has been used. Foley is that a sound where we generally use the sound of footstep or door or something like that, which is not synced at that time, but we can later input that sound effects with that foley and ambient integration. How we did this is the entire flow chart. We can see that how it has been used. Input signals has been sync sound first, then time frequency processing has been used, little bit spectral repair and using complex ratio masking, then reverberation de-reverberation has been used, then equalization with the equalizer, as I earlier just said, then dynamic range compression is necessary, the because we have used the dubbing process, so might be it is loud because the mic is nearby to the character or the person who is acting over there, so loudness normalization is necessary. Then, as I said, the footstep or something like that, other no, voices, that is included in a foley and ambient integration, and then the final output, audio master has given this audio. How AI analyze the validity and metrics. The for P2V is called as the phoneme to visime. It means audio to visual correlation used for quantifying the alignment, which is threshold is 0.85 nearby. Uh, Temporal drift threshold set as 22 ms. Ms is the industry standard. SNR threshold is 15 to 18 decibel for reliable processing. That is the industry standard. We followed that, and we have checked that with the analysis. Uh, confidence uh, Confidence scoring 0 to 100 label, usable segment, earphone error prone segment. Trial run findings, what we trial run, trial run findings, technical issues we faced. We understood that what happens over there. The outdoor recordings caused spectral masking. AI missed most of the many plosive or predictive phonemes. Why? Because it's definitely outdoor recordings have traffics and other ambient voice. That is why AM is that. Indoor non-treated rooms caused reverberation. Obviously, we can understand if it is a large room, the reverberation is there. Echo, we
Dear
generally,
presenter,
yeah, yeah.
I'm
I'm
sorry
about to
to.
finish.
Okay, okay.
Yeah. Uh, sorry, I was there. Indoor non-treated rooms. It is large rooms, so generally jitter is there or reverb is there, echo is there. So that technical issue is over there. Studio dubbing provided highest AI confidence. Nearly literally, we got that to 98%. It's completely high fidelity signal because it's dubbing. It obviously has to give that quantitative result in phase 1, phase 2, phase 3 is a peak peak in a peak volume minus 15.12. Phase 2 it is 6.89, and in a phase 3 it is absolute optimized level for the third phase. Average SNR sound noise ratio, that is 8 for 8 dB decibel for phase 1, for phase 2 14, and for phase 3 20 decibel. Pardon me for the mic. P2V correlation are is 0.62, phase 2 0.78, and for phase 3 0.96. 96 is the best one correlation of a P2V. Temporal drift should be lesser. uh, in first phase, 42 is 42 ms. In phase 1 and phase 2 it is 18, and phase 3 it is 5. So what we wanted to achieve is a lesser 1 ms. We got that in phase 3. Discussing an implication, sync sound preserves performances nuances, but often fails technical threshold for AI lip sync, as we discussed earlier. ADR delivers the SNR and frequency clarity required for the reliable P2V mapping and neural processing. Hybrid approach captures performances on set plus studio ADR for the production grade AI alignment. And the last one, conclusion and future work. Studio dubbing is a technical benchmark for the AI assisted lip sync. Sync sound remains valuable for the performance references. Obviously, we all know about that. Future work, multiple scenes and genres, biometric measures, real-time AI denoising, acquisition through the software. We can achieve that. Cross-cultural studies can be done. The key takeaways from this is acoustic integrity is fundamental for AI lip sync reliability, P2V correlation, and SNR threshold supposed to be maintained for that. Thank you.
Thank you so much. Do we have any questions?
Yes, one question. Actually, your work is very good. And I have one question like how much data set is used for training and testing purpose? Or
See, ma'am, first thing is that sorry, first thing is that we though we see this three different shots have been taken, but for actual it is literally if considered it is 50 GB data has been used for that entire shot and audio and all these things at one time, and we tried multiple testing by 3 times. So literally 150 GB data, nearby to 150 GB data has been utilized for this experiment and all this kind of things.
so you have collected, I mean, it's a freely available data set or you
No,
have
no, no, no,
collected?
no, no, no. We shot this. See,
Okay.
do I need to share the screen again for showing you that particularly?
No, no, it's you can just tell me.
You should, I have seen phase one, phase two, phase
Yes,
three
yes.
screenshots, right?
Correct,
One
correct.
is outdoor, one is in the room, and third one is in the
Mm-hmm.
complete studio. So we shot this three different sets in a three different way times.
Yes.
So
Okay.
that is completely shot and recorded in our
Mm-hmm.
studios and
Okay.
outdoor also in the
Okay.
university.
Okay. Got it. Got it. Thank you.
Okay, thank you so much, ma'am.
Thank you so much for that presentation.
Thank you,
Moving
ma'am.
forward, we have Thoraj Sairaj Dada Saheb with the paper title AI Driven Yield Prediction System for Sugarcane Crops Using Multispectral Satellite Data and Weather Parameters. Dear presenter, you may start presenting.
Hello, ma'am. Am I audible well?
Yes, sir.
Let me share my screen.
Yes.
Good afternoon, everyone. My name is Cyrus Thorat, and on behalf of my entire team, I am here to present our work titled AI-driven yield prediction system for sugarcane crops using multispectral satellite data and weather parameter. And I am truly grateful for this opportunity to share our research with you today. Uh, uh, so before talk about our technology, let's talk about why this problem matters. According to the National Bureau of Crime, nearly 1 lakh farmers and agricultural laborers died by suicide between year 2014 and 2022. That's over 11,000 lives lost every single year. Most cited reason is not drought or disease, it's debt. Farmers borrow money expecting a certain yield and a certain price, and when reality falls short, they are left with loans they simply cannot repay. And why can't they predict this? Because they don't know their yield until harvest, and they don't know market value until it's too late to act. Without without the proper planning, uh, it is impossible. It is impossible to plan when to irrigate, when to plant, or when to sell. Maharashtra is a largest sugarcane producer, yet the most farmers still rely on traditional experience-based estimation. No data, no forecasting. Our solution changes that. Using multispectral satellite data and weather parameter, a farmer can estimate how much his sugarcane crop will yield and earn while it's still in the standing field. So, what exactly is broken in the current system? First, the official method is a crop cutting experience, which is a manual and slow. It takes 3 to 5 person days per hectare, and even then, it only gives a district level average with an error margin of plus or minus 15%. That's not precision. That's a rough guess delivered too late to act on. Second, the research that does use AI tends to look at only one piece of puzzle, either satellite image alone or weather data alone, never both together. So the model misses half of the story every time. And the third, many of these studies test their model on randomly shuffled data instead of respecting the season. That's like a letting the model pick the future before predicting it. It inflates the accuracy on paper but fails in the real world. So our objective was simple: build a framework that fuses satellite vegetation indices, weather data, and agronomic factors like soil type, etc. together. Validate it strictly by harvest year, so it's tested only on genuinely unseen future seasons. Benchmark it against the standard models and identify exactly which factor drive yield the most, all at scales that cover the 14 taluka over 6 years. So these are some of the main research paper we use. The most helpful was Sherza Akbarian's a plot level sugarcane yield estimation by machine learning, and which actually uses a multispectral images. Uh, and it has a very important advantage that it uses the approach that we are actually using it. So let's walk through the how the system actually works. So we have built a three-stage pipeline. In the first stage, data acquisition and feature engineering, we pull vegetation indices like NDVI, EVI from Sentinel to satellite, land surface temperature from Landsat 8 satellite, and the few weather variable from NASA power. We combine these with multiple agronomics details like soil type, irrigation method, cultivar, planting dates, and giving us multiple feature per field per season. Before training, we clean these data, normalizing values, capping outliers, encoding categorical variables like soil types numerically. For the second stage, model architecture, we use random forest and ensemble learning methods that combines multiple decision trees through a bootstrap aggregation or bagging to reduce the variance and uh, avoid the errors. Handles high dimensional agronomics dataset and captures nonlinear interaction between satellites, weather, and agronomic features without requiring extensive feature scaling, making it robust and reliable for real world field data. Finally, for a validation, we didn't shuffle our data randomly. We split it strictly by harvest year, training on 2019 to 2022, validating on next year, and testing on only the final most recent seasons, 2023 to 2024. So our result reflects real world forecasting, not hindsight. So now let's look at what actually powered this system. Our data set covers 10,000 fields observations spanning 14 talukas of Ahmednagar districts across the 6 harvest years from 2019 to 2024. Ground truth yield values came from the strict agricultural registers, ranging from about 39 to 180 tons per hectare. Out of our 34 features, 3 come from a satellite, which are NDVI, EVI, and a land surface temperature. Few come from weather, which are temperature, solar radiation, humidity, rainfall, and the remaining 26 are agronomics, things like soil type, irrigation method, and planting dates. uh, the 70% of the training covering 2000 to 2019 to 2022 are used for training, 15% for validation, and the final 15%, the most recent season, are reserved purely for testing. On the technical side, everything was built in Python using scikit-learn for pre-processing and baseline models, and Optuna for hyperparameter tuning, all running on the standard CPU workstations. No specialized hardware required. This makes the entire pipeline lightweight, reproducible, and realistically deployed for the agriculture advisory use. So these are some of the important result and some evolution matrix of our system. But let me show you our actual model how it works. Uh, Give me a second. So this is the interface we can provide, and where we can add multiple fields like with their field name. like suppose we have added this field, and then we need to map where is suppose we have to mark where is our field, then how much acres of land it is automatically calculated. So to suppose 2 acres of land is marked by farmer, then he need to give some input to our model, like simple input which can be provided by any farmers. So which are soil type, which season he is planting in, his sugarcane variety or planting date, and then on this dashboard he can actually get how many tons per hectare, and how many rupees per ton will cost. He will get a price, and also his revenue for this year, and some other important things. So this is how our model works. And going to the next part, which is conclusion. So we set out to solve a real world problem uh, for the farmers unable to predict their sugarcane until it's too late to act. By fusing the satellite vegetation indices and weather data and agronomic factors, our model achieved a R square of 0.85 with a mean absolute error of just 8.55 tons per hectare, outperforming the baseline approaches and a prior satellites only studies on Indian sugarcanes. Three things came out clearly. One, combining multiple data sources give us a 25% improvement over using a satellite data alone. Second, NDVI, the vegetation greenish index, turned out to be the single strongest predictor of the yield. Looking ahead, we plan to incorporate with SAR imagery and soil moisture data to make the model even more robust, especially under cloud cover. And ultimately, we want to build a simple farmer-facing advisory tool in a regional language. So this technology reaches the people who need it most, and turning a research framework into a real solution for Indian sugarcane farmers. And this was from me, and I'm open for the question.
Thank you so much for that presentation. Do we have any questions? Okay, you can stop.
Can I ask one question?
Yeah, sure.
Yeah, the very nice, wonderful work you have done for the sugarcane farmers. If you could have arranged here the YOLO, the latest version, you would be able to create the proper dimensions of the land which you are taking. It could be the more also. And the second one, I wanted to just ask you, have you taken for like the leakage is there, no? Temporal data leakage. So you have taken a rolling window validation because it works, or even you can do that 1 year out of the cross validation. Though you
Uh,
have taken the separate for the training, separate for the validation, and separate for the testing, years for the data.
yes,
But it
ma'am.
will work very good in your project only if you want the correct prediction, because whatever things you are considering and if you are predicting, quite possible some unavoidable situations are leaving it.
Yes, ma'am.
So in spite of only taking the 5 years data, if you'll go for more number of data years, and you can leave 1 year out cross validation, or even you can do the expanding window validation. Like in time series, we are doing that, right? That you can do. And if you'll go for the YOLO, then this anomalies which are unnecessarily taking your prediction not at the correct level would be able to help you.
Yes, ma'am. Thank you for your suggestion, ma'am.
Welcome. Thank you very much.
Thank you so much. Next, we have Anjali More with the paper title Artificial Intelligence in Histopathological Cancer Detection Methods, Challenges, and Future Directions. Dear presenter, you may start presenting.
Yes, ma'am. My screen is visible, ma'am.
Yes, ma'am.
Hello. Good afternoon, respected chairperson, honorable guests, and fellow researchers. It is my privilege to present my research work on artificial intelligence in histopathological cancer detection methods, challenges, and future direction. I am Anjali More, a PhD research scholar from the School of Engineering, Avantika University, Ujjain. And my guide name is Dr. Ashish Bhansal sir, School of Engineering, Avantika University, Ujjain. This work focuses on how artificial intelligence can support the pathologists in the detecting cancer more accurately and efficiently. And in this, first of all, histopathology is considered the gold standard for cancer diagnosis because it involves the microscopic examinations of tissue samples. However, this process is manual, time consuming, and highly dependent on the expertise of pathologists. And also, different experts may interrupt the same slide differently, which leads to enter observer variability. And we can also say that in this research, an artificial intelligence provide an automated approaches that reduce the human efforts and improve the consistency and accuracy. And the next is the motivations behind this work comes from the increasing the number of the cancer cases worldwide, and this has significantly increased the workload on pathologists. And there is a strong need for a system that can assist the doctor in faster and more reliable diagnosis. And in this, we will use the AI-based system that can act decision support, like tools and help the reduce the human error. And in this, the data set for training, we will use the training AI models. Several publicly available data sets are used, such as Big Case, Chameleon 16, PCGA, etc. And these data sets contain the histopathological images of different cancer types, like breast cancer, lung cancer, and colon cancer. Using diverse data sets help to improve the model and generalization and robustness also. And next in this, AI techniques. In AI techniques, the various AI techniques are applied in this domain. Like CNN is mainly used for the classification task, and UNet is widely used for segmentation of the tumor region. And we will use the transformer also capture the global relationships in the images. And MIL is useful when only weak labels are available. Each technical has its own strain and depending on the problems. And CNN details. And in this, we will discuss this convolution neural network automatically extract the important features from the images. images like tissues images and different types of images we will use in cancer, and they are very effective for the classification task and achieve high accuracy. However, CNN mainly focus on local features and miss the global context. And next is our UNet details. UNIT is an encoder-decoder architecture and used for the precise segmentation. It helps is identifying the exact tumor region and the pixel level. However, it requires the computational resources. And the next transformer process images as pages and capture the global dependencies. They provide a better contextual understanding compared on the CNN. However, they require large data set or high computational power. And the next is AI pipeline. Next is AI pipeline. In the first step, we will start the histopathological images, which are medical images used for analyzing the tissues. And the step two, we perform the pre-processing. This step include the cleaning the data, resizing images, and improve the quality so that the model can understand it better. And in third step, AI model, we use an AI model. The model analyzes the precise images and learn the pattern from the data. In the fourth step, we evaluate the model the performance using the different metrics to check the how accurate and reliable it is. And finally, in the step 5, based on the model output, we get the diagnosis, which help is identifying the diseases. So these pipelines show the complete flow from input data to final diagnosis using the AI. And the last, these slides explain the AI pipeline. First, we take histopathological images, then pre-process them. After that, the AI model analyzes the data, we evaluate its performance, and finally, we get the diagnosis. And the next is pre-processing. Pre-processing improves the image's quality and consistency. It includes standard normalization, resizing, and augmentation and noise removal. And these steps play a crucial role in improving the model performance. And next is model training. Deep learning models such as ResNet, VGG, and DenseNet are trained using label data. These models automatically learn features and improve the detections accuracy or the time. And next is evolution matrix. And evolution matrix, in this evolution matrix help the measure model performance. Accuracy measures the correctness, precision measure correctness of positive predictions recall, measure detection ability, and F1 score balance both. And next is challenges in this. Despite the advancement, several challenges exist. Dataset imbalance, stand variability, lack of explainability, and high computational cost are major issues. These challenges limited real world adoptions also. And future work in this, future researchers focus on explainable AI, federated learning, lightweighted model, and clinical validations also. And these advancements will make AI system more reliable and practical also. And in conclusion, and AI significantly enhanced cancer detection accuracy and deep learning method outperform the traditional technique. However, future researchers need to real world deployment also. And AI improve the diagnosis accuracy, deep learning outperform traditional method. Future research is needed. Thank you for your attention.
Thank you so much. Do we have any questions? Okay, thank you.
Thank you, ma'am.
Up next, we have Krishnanchu Ramjiwala with the paper title AWRAG Improving Pedagogical Saliency in Retrieval Augmented Generation through Acoustic Weighting and Edge Based Inference. Dear presenter, you may start presenting.
Okay. Is my screen visible?
Yes, sir.
So, hello everyone. So the topic is AW-RAG improving pedagogical saliency in retrieval augmented generation through acoustic weighting and age-based inference. So paper ID is 1640. So the problem with the traditional RAG is currently when the students use RAG systems to query lecture recordings, the models only look at the transcript text, but the human communication is heavily acoustic, heavily acoustic. If a professor loudly emphasizes a critical exam topic, the text transcript doesn't capture the urgency. Our text only baselines were drowning in the semantic noise, treating every word as equally important. So the proposed solution AW-RAG. To solve this, we introduce AW-RAG. Instead of just searching text, our framework analyzes the vocal properties of the lecturer, like tone and stress, by mapping the speech emotion and porosity alongside the text. We can actively prioritize the segments where the lecturer is exhibiting high arousal or emphasis. The core architecture during the retrieval phase, chunks of lecture aren't just ranked by how closely the text matches the user's query. We apply an acoustic weight. Apply an acoustic weight. Segments that were spoken with arousal or clear pedagogical emphasis receive some multiplier, pushing them to top of the context window. Age-based inference. For the generation stage, we didn't want to rely on expensive latency cloud APIs. Instead, we deployed a quantized local model on the edge. This is not only speeds up the inference time for the end users, but also ensures the proprietary university lectures and student queries remain completely private and on device. Results and evaluation. When we evaluate the model, the results were distinct by weeding out the semantic noise. AWRAG dramatically outperformed the baseline. For example, when querying the system for exam tips or core concepts, our accuracy jumped significantly because the model knew exactly where the professor raised their voice to signal importance. So now demonstrating the baseline RAG, AW. This brief visual shows the system in action. As you can see, when asked to summarize the core takeaway, the baseline misses the point. When asked about what is most important concept in modern AI, the baseline model struggles to answer and focuses on not required part of the text instead of focusing on the correct concept. AWRAG. AWRAG correctly identifies the segment where the lecturer's tone shifted, pulling the exact concept the student need to study. It also assigns higher priority to the emphasized context in the speech transcription. AWRAC doesn't deviate from the question asked and solely focused on the important concept given in the transcript, leading to better performance of the RAG system. Then conclusion and future scope. To conclude, treating lectures purely as text leaves too much value on the table. By combining acoustic weighting with the age based generation, we can create smarter, privacy preserved educational tools. Moving forward, we aim to expand this architecture to handle multilingual emotion detection and real time classroom feedback. Thank you.
Thank you so much. Does anyone have any questions?
Yes. Uh, Actually, I have one question like, how did you evaluate the retrieval quality of your data? Quality, how you checked?
We use the some audio samples to test the quality, and through that, most of the cases it performed well.
Any real-time data you have collected?
We have tested with the audios clips.
Okay. Okay, fine.
Okay, ma'am.
Thank you so much. Next, we have Kesavulu Pula with their paper title Distribution Shift Penalize Learning for Fair Income Prediction on Imbalanced Census Data. Dear presenter, you may start presenting.
Am I audible?
Sir, your voice is a little low.
Is it now okay now?
Yes, sir.
No. Let me share my screen.
Yes, sir.
Good afternoon, Session Chair, and good afternoon, fellow presenters. I'm Dr. Keshav Pula from Department of Management Studies, Jai University, Bangalore. Let me start with a scenario where there are two candidates, male and female, who applied for the bank loan. The same set of qualification features like same salary levels, same civil and appraisal scores, same expenditure pattern, and uh, similar kind of features. In that bank rejected the female application, were accepted by the male applications. And bank is telling that the model is so accurate with respect to the accuracy. Now there is a question in the mind that is the model accuracy is the only measure to to predict the data or to predict the future. Absolutely, in some cases not. With this motivation, we work with the title called Distribution Shift Penalized Learning for Fair Income Prediction on Imbalanced Census Data. Come down to the introduction part, of course, we see that the literatures and all the previous studies, we all know that machine learning models today is widely used models with respect to the many organizations, especially in banking, finance, healthcare, recruitment, in government welfare organizations also. If you see down the line of decades of research, many researchers will predict the model and will tell the model is so good based on the accuracy, precision, and area under. So there is a question that these metrics are really fair enough to tell the model is really best. And of course, there are some models provides 95% accuracy, where they were failed touch with some demographic factors or demographic features called gender, sex, with gender ratio, with race, and other socio-economic factors. And of course, I come up with a real case study where it happened in 2015 with the Amazon AI recruitment. Amazon started, ATS application tracking system with a machine learning model, and of course, before they tried the last 10 years of data. But unfortunately, in 21 to 2010, in the tech world led by the no, male domination, where the model is trained in a way that the males are the successful candidates. After implementing the model in 2014 to 2018, they understood that there's something wrong with the model, that majority of the male applications only screen. So it means that the model is absolutely accurate, but the training with respect to the fairness factors is not correct. With this motivation, we have selected this research. Yes, there is a strong literature gap with respect to the socio-economic factors. And if you see all the studies, what actually I referred through my study, and there are three steps involving in all these phases: pre-processing, in-processing, and post-processing. And we all know the pre-processing is all about people used to resample, reweighting, and of course they balance the data with the advanced SNOT techniques, synthetic minority oversampling techniques. And of course, in processing, we use some advertisal debiasing by making complex relations, connecting to the complex relations and train the data to get more advanced results. And of course, post processing, this is little interesting that to adjust the threshold after the training data. These are all the quite common methods people used to do for all the researchers. But what is the missing? Yes, there is a missing concept called fairness prediction. Yes, absolutely, I agree that the model prediction accuracy rates are so high. But will they really test with the fairness group with respect to gender, or with respect to race, or with respect to other socio-economic factors? That's why we introduced a new proposed model called DSPL, Distribution Shift Penalized Learning. The flow goes like this. Yes, we will get the data, original data, and of course, I'll down the line, I'll explain in the future slides how to clean standardization, how to fit what are the models that we have used. And we have used one new adjustment called visit time distance. This plays the key role in balancing the data. Come down to the data selection. Yes, we have collected a data from open Open platform, it is collected from UCI repositories related to US Census Bureau data. And if you see the data, that whatever the complications that the data needs, all complications are there. There is a mixed type, numerical, categorical, socioeconomic factors, and the class imbalance is there. If you see the data, that the male data is more, female data is little less, and there are some proxy features where it looks like same with respect to the correlation, where it creates a multi-collinearity effect. So that is why we have selected this complicated data to test it. Yes, and this is what the whole study goes to, two lens fairness. One is outcome-based fairness, the second one is distribution-based fairness. With respect to statistical parity difference, it measures the different demographic groups relative positive predicting scores at the similar rate. I'll come up with one example. Take, for example, there is 100 male applications and 100 female applications. If the model selected only 40 male applications and the 20 female applications, and the difference is 20%, 40 minus 20. No, it should not be like that if the applicants are having the same features. It should be close to zero. That we are going to locate with the SPD. And the next one is disparate impact. Rather than measuring the difference, we are going to check with the ratio. If you see that example, that there is a ratio called 20 applications of female, 40 applications of male, the 20 to 40, it becomes 0.5 differences. No, it should close to 1. It has to match to 1. So in this case, we used versatile distance in order to balance male and female applications. I'll show how versatile distance will work. As per this method, we can strongly say that yes, machine learning minimizes the prediction error. I can agree, but our model not only minimizes the prediction error, but also it reduces the fairness error also. And this is what the mathematical application, where the lambda is the classification loss. It will play the crucial role. And this is what the procedure, how the versatile distances balance the data with respect to the gender. If you see that the before DSP, there is a lot of male domination. I mean, male applicants are more with respect to the female, and obviously it's imbalanced. Future previous researchers told that previous researchers they balanced with different techniques, but here we have used versatile distance with the concept of minimum effort. So versatile distance actually calculated and balanced the male and female by using mass into distance. By calculating the mass value with respect to the how much distance between the samples, and it accordingly it will calculate and it will increase the female samples and matching to the male. So then we are going to balance the whole data. And after performing the whole model, this is actually before using the what is this R model. If you see that we have applied the base model as a logistic regression, and of course we have used random forest predictions. So here XGBoost really performed well with accuracy of 0.86 with a AUC of 0.92. But still, there is a complexity with this model. Accuracy is so good, but what about the fairness? If you see that there is a strong gender bias existed across all the models. This gender bias is not, with this gender bias, we can say that the model prediction somewhere goes wrong with respect to the fairness concept. So then, if you see that the random forest also shows that widest gap with almost 0.18. So then we applied the DSPM with removes almost the minimal after applying the DSPL rule, yes, it reduces little accuracy level. Obviously, that now when we are going to the deep into the crossroads, the model accuracy will reduce, but the performance of the model with respect to fairness is increased to 33%. Before it was close to 0.17. After applying the versatile, it come to 0.11. So with this results, we can somewhere confirm that we can't look at the model accuracy alone. Sometimes we have to look into the fairness with respect to the socio-economic factors. And if you see this picture, that how DSPL substantially narrowed down the gap between demographics. Uh, LR model, when logistic regression is the dotted line we have mentioned after applying the DSPL. If you see the graph, male and female is closing somewhere after the 0.5 distribution, after the 0.5 values, and those who are having more than 50K of income levels. And with this results, we can say that yes, absolutely accuracy is very important. But in many cases, not only accuracy, we have to see the fairness levels data. And when you look at the fairness level, you may get little low in accuracy, but you will provide a good insights to the model that where we can justify in the nature of problem. And where it is where the complete model is depending on the Weisstein distance with the lambda value. And finally, with this results, we can say that extended DSPL method will give you a good results with respect to fairness. If you see that there is a 33% increase with the low of 2.4 point of accuracy. And of course, we are looking to this model. Now we apply it only on the gender. In future, we are going to try for the race and the other socio-economic factors also. Thank you very much.
Thank you so much. Does anyone have any questions? Okay. Thank you, sir. You may stop presenting. Next is Bhavana Mishra with the paper title IoT-based compositing alert and monitoring system. Dear presenter, you may start presenting.
Unable to share my screen. No, thank you. Is it visible now?
Yes, ma'am.
Good morning, everyone. I am Bhavna Mishra, and today I am presenting my research work titled IoT-based composting alert and monitoring system. This work focuses on automating the composting process using IoT technology. Here is the outline of my presentation. Now, first of all, what is IoT? IoT refers to a network of physical devices equipped with sensors, processors, and communication technologies that allow them to collect and exchange data over the internet. And this capability inspired us to apply IoT to compost monitoring. Here, the application of IoT, and it is available in almost every field. Similarly, it is widely used in healthcare, smart homes, industrial automation, transportations, and environmental monitoring. Our research specifically focuses on its agriculture applications. Here is the motivation of my project. Where traditional composting requires continuous observation and frequent manual measurements. Maintaining suitable temperature, moisture, and pH is critical because even slight deviation can delay compost maturity or reduce compost quality. Manual monitoring is time consuming, labor intensive, and often unreliable. Therefore, we were motivated to develop an IoT based automated monitoring system capable of continuously tracking compost conditions and instantly notifying users whenever corrective action is required. These are the objective of my research. First is to study IoT application in agriculture. Second is to develop an efficient compost monitoring and alert system. And finally, to evaluate the performance of the developed system compared with conventional manual monitoring methods. These are the material and methods we have used. And hardware components include an Arduino Uno and with Atmega 328 microcontroller, ESP8266 Wi-Fi module for internet connectivity, temperature, moisture, and pH sensors for data collection, along with supporting components like LED, buzzer, resistor, capacitors. Each sensor continuously measure one important compost parameter. These are the software tools which includes Arduino IDE for programming, the controller, Eagle for circuit design, ThinkSpeak cloud platform for real-time data visualization and storage, and virtual mobile application for remote monitoring and notification. First of all, what is composting? Composting is a biological process where microorganisms decompose organic waste into nutrient-rich compost. For efficient decomposition, microorganisms require a balanced supply of carbon, nitrogen, oxygen, moisture, and an appropriate temperature. Maintaining these parameters within their optimal ranges significantly improve compost quality and reduces decomposition time. This is the composting process where initially microorganisms become active, causing the temperature to rise rapidly. As decomposition progresses, organic matter breaks down and eventually stabilizes, producing mature compost suitable for agricultural applications. Continuous monitoring throughout these stages is essential. And through this monitoring devices, we will store the information on IoT server, which will going to alert the users when compost will going to mature. These are the factors affecting composting process, where temperature should be between 20 to 70 degrees Celsius, moisture should be between 40 to 60%, and pH value should be 3 to 7 range. Oxygen should be above 5%. Our system continuously monitors temperature, moisture, and pH. Whenever these parameters move outside the acceptable range, the system automatically generates an alert. This is the block diagram of my IoT-based composting alert and monitoring system. The sensors collect environmental data and send it to the Arduino controller. The Arduino process the information and forward it to the ESP8266 Wi-Fi module to the ThinkSpeak cloud. The cloud stores the data and simultaneously sends updates and notification to the user's mobile application. These are the steps we have followed in composting alert and monitoring system. The system works in a simple sequence. First, the sensors measure compost condition. Second, the controller compares the sensor reading and predefined threshold value. And then third, the processed data is uploaded to the cloud. Finally, whenever abnormal conditions are detected, users immediately receive notification on their smartphone. This is the circuit design of IoT-based composting alert and monitoring system. All sensors are interfaced with Arduino, while the ESP8266 provide wireless communication. The design ensures continuous monitoring with minimal power consumption and reliable data transmission. These are the results we have found. These readings confirm that the sensors successfully require temperature, moisture, and pH value in real time. And this result demonstrates the system capability to identify immature compost whenever the monitored parameter indicate that compost has not reached maturity. The system immediately recognizes the condition and prepares an alert. These graphs are obtained from the ThinkSpeak cloud platform. Uh, field one Field one displays temperature, and field two displays the moisture value, while field three represent the pH value. These continuously updated graphs allow users to monitor compost condition remotely and observe changes over time. This slide shows the configuration required for connecting the mobile application with the cloud platform. Once connected, users can monitor real-time sensor data directly on their smartphones without being physically present at the composting site. It demonstrates one of the key features of our system. Whenever compost condition become unfavorable or immature, the user instantly receives a notification on the mobile devices. This enables timely intervention and prevent deterioration of compost quality. Here's the conclusion of my proposed IoT-based compost monitoring system. It automates the monitoring process. Uh, it reduces manual effort, minimizes monitoring cost, provide real-time alerts, enable remote supervision, and improves the efficiency of compost production. Overall, the developed system offers a practical and economical solution for modern compost management. Here's the future scope of my monitoring alert, where additional parameters such as carbon to nitrogen ratio can be integrated into the system. Also, advanced machine learning technique can also be incorporated to predict compost maturity automatically and provide intelligent recommendation for process optimization. These are the references we have used in the alert system. I sincerely acknowledge the contribution of these researchers. Thank you all for your kind attention. I would be happy to answer any question or discuss any aspect of this research. Thank you.
Thank you so much. Does anyone have any questions?
Yes, may I ask one question, a very small question? Good
Yes,
presentation.
yes, thank you.
Yeah, the aspect is also good. A very small thing, Arduino, you are using in a microcontroller way.
Yes, ma'am.
Suggestions also I want to give, but my first question is that how does the Arduino, what you are using the microcontroller to collecting the data, like you are adding moisture, temperature, all. So Arduino can display it very well. So what is the procedure you are collecting them by using their sensors, and how you are changing it to real time so that you can get the monitoring and alerts?
Yes,
Which
ma'am.
software you
Ma'am, if I understood your question, like you want to know how software and hardware communicate each other.
Yes, yes. How
Okay,
do
ma'am.
you do the interfacing? And
Okay.
because you have used the cloud computing also over
Yes,
here,
yes, ma'am. Yes, ma'am.
so how you have developed that? Which is the interfacing, complete interfacing of data set and your cloud computing response?
Ma'am, actually, I have communicated through like sensors generate analog and digital signal, which is processed by ESP8211. Um,
That one is with the
Hardware.
Arduino, dear. That one is
Yes,
with the
ma'am.
Arduino, dear. I just want
Yes,
to ask the interfacing, you are directly going to the cloud. Are
yes,
you
ma'am.
some containers and all? Are you getting the data? Because now whatever the data you are getting, your app is converting into the real time data that this thing is happening and this is the moisture level. I need to give the water to the plant.
Ma'am, that I have done through the ThinkSpeak cloud server.
Okay. Okay. So
Yes,
if
ma'am.
you will go and if you will take
Ma'am, that provides us the
things speak.
real-time
Okay.
visualization and easy API integration.
Right. So API, when you are talking about the API and things speak, it is
Yes,
losing your data. So you need to first do for the historical data. And once you will do the analysis of the historical data, based on that, the new technology with the ThinkSpeak, if you will coordinate, then it would give you the perfect answers.
Yes, ma'am. That is what I have to do in my future work.
Yeah,
uh,
because
project.
you know whatever you have done, it is like you're giving the data from the Arduino, connecting
Yes,
to
ma'am.
IoT, giving it to the sensors, making it things speak, and the APIs are giving the data. That should be correct also. All right.
Yes, ma'am.
All the best. Thank you very
Okay,
much.
thank you.
Welcome.
Thank you so much. We may stop presenting now.
Welcome.
Next, we have Dharsaj Kaushal with the paper title MCP Deep Researcher, Smart Search, Reliable Research, and Strong Collaboration. Dear presenter, you may start presenting.
Um, yes, good evening. Am I audible?
Yes, sir.
Yes, so good evening, everybody present here. My name is Drasaj Kaushal, and here I am here to present MCP Deep Researcher, a software research tool developed by the students of Ajinkya DY Patil University, namely uh, Sajid, Shivtej, Prashant, and myself under the guidance of Dr. Vishal and Dr. Ranjit, who are also from Ajinkya DY Patil University, and then Dr. Anupriya and Dr. Sheetal from Vishwakarma University and Symbiosis University, all of us residing in Pune. So let's get let's move forward. So this is the agenda. These are the topics we'll be covering today. And let me first introduce you to MCP Deep Researcher. So MCP, so the main problem currently that a lot of researchers face right now is that uh, Archive recently reported that their the number of documents in the database has exceeded 3 million, and every month at least 30 to 40,000 documents are being added now. So the thing is that when researchers like students and uh, uh, professors, scientists, they when they want to find specific documents related to certain topics, they face a lot of difficulty finding these papers. For example, you may have a lot of tabs open, like some tabs on of Semantic Scholar, some tabs of PubMed, some tabs of Archive, then some from Google Scholar. And so basically, what MCP Deep Researcher aims to do is that because most proprietary AI tools are closed source and cloud dependent, and they lack integration with also regional databases, which is a point I'll cover later on. Uh, by leveraging MCP, we built a self-hosted, privacy-centric solution. So first of all, what is MCP? MCP is its full for Model Context Protocol. It is a protocol which was released by Anthropic in late 2024. What it allows you to do is that you can connect external tools uh, which are defined within NCP servers. You can connect those tools to clients like Claude Desktop or Chat GPT. So before, what the issue was that when you are using these clients like Claude Desktop or Chat GPT or Cursor, you are limited to the context on in that specific tab. You cannot uh, ma- uh, make calls outside that specific window. But what MCP allows you to do is you can connect a multiple, like hundreds and thousands of uh, databases or API integrations to a client. So and it is as I've mentioned over here, MCP is also called as a USB-C port for AI because it provides a standardized interface to connect LLMs with specialized databases. Here we are using academic databases. So let's move on to the objectives. So the primary objectives are that we want to make sure that the source retrieval is unified. That is, we can establish a single point of access for all global repositories, be it archive or a semantic scholar or any regional database which provides thesis like Shod Ganga. Then we provide semantic concept discovery. Then we provide contextual RAG synthesis. Then standardized extensibility, privacy centric autonomy, and provenance and traceability. All of this allows you to all of this works at in a self-hosted privacy-centric way. So how was the work split? So basically, the core architecture was divided into three streams. The system engineering and MCP protocol integration, which handles the STDIO communication and JSON RPC, and then the data pipelines and scraping, like usage of the archive API, and then uh, scraping of the Shod platform using Beautiful Soup, and then the AI and RAG evaluation. So the before starting this project, because as I said, MCP is a very or you can say relatively new protocol, so there is literally no documentation or very limited documentation available for it. So what we thought is that because Anthropic is the only documentation provider for MCP, we can because MCP connects with LLMs to connects with LLMs and agents, we can perform literature surveys on security related uh,
Dear
issues.
presenter,
Yes, yes.
I'm sorry to interrupt, but you've further crossed the 9-minute mark. Please conclude your presentation soon.
Yeah, yeah, yeah. So basically, our main goal during the literature survey, we found out that the MCP servers and other LLMs, they face a lot of issues like like that of discovery fragmentation and then contextual contamination. Like for example, prompt injection or bias towards certain repositories, which we have fixed in our project. So let's move on to the methodology. So the processing pipeline, it basically use we use the archive API, semantic scholar API, and then web scraping on the Shotganga platform to uh, extract PDFs and text from those specific platforms, and then we use PyPDF2 to basically process the whole all the papers, and then we use a modular architecture where the five primary layers are multi-source retrieval, document processing, and vector indexing. Alongside of that, we also use a RAG engine, and of course the main thing, the MCP interface. As I said earlier, the main benefit is unified paper retrieval. That is all papers from all the platforms. We can store them together and sort of interact with those all of our stored documents at in a single platform. So the experimental work, that is the first one, is the dual mode RAG architecture, where the first mode is the MCP mode, the second mode is the LLM mode. The LLM mode is basically you using a local model to uh, uh, to interact with the stored documents on which have been retrieved using the archive or semantic scholar API, and then the MCP mode, which you can use using the client your desktop like Claude Desktop or any other external host. And then there's the vector indexing performance. We use the mini LM-L6 v2 model for fast inference because it is very highly accurate in STEM benchmarks, and it is also very small, like only 80 MB. So we can run it easily locally. We expose five specialized tools, that is search papers, search Ganga, ask papers, get paper summary, and list stored papers to all of our desktop clients, which they can use to perform these specific tasks. And then there's also the communication protocol, which I've talked about earlier, and the web application interface. It is basically a self-hosted front-end dashboard that translates all the complex rank operations into a intuitive environment for non-technical users. So the results, the first is that we successfully implemented the MCP server and the front-end interface, which I talked about earlier. Then we enhanced the retrieval performance. That is, we made sure that uh, all the system is retrieving documents which match the query of the user. We also added operational versatility. That is, we also added a command line interface for highly technical users. uh, and then there are also some limitations that we faced. That is the processing challenges, that because PyPDF 2, the library, it faces a lot of issues when extracting mathematical information from papers, because a lot of papers contain a lot of mathematical uh, formulas or diagrams. And then there is also the language barrier. That is, this uh, uh, tool, it can currently only supports English. And then also network stability. That is, Ganga retrieval is occasionally impacted by server side timeouts from their side. So the main conclusion is that we have developed a unified research ecosystem. We have added security based on the guidelines of the OWASP Foundation. We have added dual mode flexibility, like I said, the LLM mode and the MCP mode. Then there is also the reliability and trust, because everything is happening locally. There are close to zero reliability on trust issues. And then the accessibility, it is very easy to set up on your device. So the future work, what we plan to add in the future is multimodal intelligence, basically implementation of vision language models and OCR pipelines to process charts, tables, and figures, like I said earlier, which we face as an issue right now. Then advanced personalization, then cross-lingual capabilities, system scaling, database expansion, and hardened security. These are some of the references. So yeah, thank you. And once again, this presentation was presented by me, the research Kaushal, and if you have any questions, you're free to ask them.
Thank you so much. Do we have any questions? Okay. Now we have Sargun with the paper title Role of HEI in Gender Equality Pathways to Fulfill SDG 5. Dear presenter, you may start presenting.
Hi, am I audible?
Yes.
Good afternoon, everyone. I'm Sargun, and today I'm presenting our paper titled Role of Higher Educational Institutes in Gender Equality Pathways to Fulfilling SDG 5. The study examines how HEIs can contribute to gender equality through institutional governance, curriculum, leadership research, and international collaboration. Now, proceeding to the next slide, let me briefly introduce the background of our study. HEIs are important drivers of Sustainable Development Goal 5 because they influence knowledge, values, leadership, and social behavior. They can promote gender equality through inclusive governance, teaching practices, and institutional culture. However, implementation remains inconsistent across institutions. The next slide. This study combines systematic literature review, bibliometric analysis, network analysis, and thematic synthesis. We analyzed 58 Scopus Index journals and articles published between 2015 and 2025 using the WAS viewer. The central finding is that gender equality initiatives are more effective when integrated into a broader sustainability framework of any institution. So, now proceeding to the next slide, let us understand the introduction and context of the study and the research questions. So, the primary research question examines the role of higher educational institutes in advancing gender equality in alignment with the Sustainable Development Goal 5, and the secondary question identifies the policies, practices, and innovations adopted by the university. The study contributes by combining bibliometric mapping with the thematic integration. Now, proceeding to the literature review. Universities are often described as gendered institutions because their structures may reproduce inequalities. Gender means gender mainstreaming, gender equality plans, and initiatives are implemented systematically across institutions.
Okay, so now let's move forward. Now we have Pranita Prashant Joshi with the paper titled Veritas Face Real-Time Deepfake Detection in Mobile Video Communication Using Hybrid Lightweight CNN. Dear presenter, you may start presenting.
Yes, sure. Am I audible?
Yes.
Okay. Good afternoon, everyone. I'm Pranita Joshi from Defense Institute of Advanced Technology, Pune. Here I am presenting my research titled Veritas Face Real-Time Deepfake Detection Using Lightweight Hybrid CNN. This is the agenda. Let's start with the introduction. What is deepfake? Deepfake technology has advanced rapidly with development of GANs and diffusion models. While these technologies have many useful applications, but also they are having lots of security threats. Today, deepfakes are increasingly being used for identity theft, financial frauds, misinformation, and also for social media attacks. Existing deepfake detection systems are mainly designed for offline forensic analysis or else they are on cloud, making them unsuitable for protecting users during live video communication. This motivated us to develop a lightweight as well as real time and also privacy preserving solution that operates entirely on mobile devices. This is the literature survey. We reviewed existing work on deepfake generation, traditional detection techniques, lightweight CNN architecture, attention mechanism, and also hybrid deep learning models. Earlier approaches relied on handcrafted features such as eye blinking and optical flow, while more recent methods uses CNNs like MobileNet, EfficientNet, ResNet also. Although these approaches achieve good accuracy, many are computationally expensive as well as they are not suitable for real time because of their weights. We also studied recent advances in lightweight CNNs, attention mechanism, and frequency-based approaches. This study shows that combining multiple feature representation can improve detection accuracy, but it also increases computational cost. So our goal was to achieve a balance between accuracy as well as efficiency. From literature survey, we identify these five major research gaps. Existing approaches struggle to balance between accuracy and efficiency. Very few solutions support real-time detection on mobile devices, but some of them are on cloud. So user privacy is not still entertained here. There are multiple systems such as Intel Fake Catcher, Sensity AI, which partially supports real-time detection, and other systems such as Deepware Scanner, and also there is one Microsoft Video Authenticator, but these are for offline detection. Many systems have poor robustness in real world condition, and they rely on cloud, as I said, so it increases privacy concerns. Uh, so to uh, reduce all these privacy concerns, we finally decided to create lightweight model which is suitable for on device detection. This is our problem statement: to detect deepfake faces in real time video call under constraints of low latency, mobile hardware limitations, and privacy preservations. Our objectives are real-time deepfake detection on mobile devices, balance between accuracy as well as latency, perform entirely on device, develop a lightweight hybrid CNN, integrated the framework with live video communication. Uh, these slides indicate proposed work. Our system or our framework follows this process pipeline. First live frame, it captures first live frames using Agora RTC SDK. Google ML Kit used to detect face and extract the facial region of interest. The cropped face is pre-processed and passed to a hybrid CNN model. And finally, the system predicts whether the frame is authentic or manipulated and displays results in real time. This is how our system works. This is entire architecture of our system. This is 5 layer architecture. Uh, First layer is data acquisition. For raw video input, we are using camera input, uh, mobile front camera input. For remote access, we are using Agora RTC that allows access to these raw video data. Frames sorted in normal YUV pixels. We have to convert them into RGB. So next layer is pre-processing and transformation layer. In this layer, conversion of YUV to RGB, because models cannot understand YUV format data. Then perform special normalization. This resizes frames into 224 by 224 and normalize pixels value between 0 to 1. This all runs in background so that uh, user cannot face UI blockage. Third layer is cascade inference, that is AI engine. This is the heart of our system. First, we detect face using MLKit, which takes 15 to 25 milliseconds, and try to find ROI, that is region of interest, to reduce computation with geometric normalization. Second, we do normalization. Uh, MobileNet V3 you MobileNet V3 extracts low-level textures with high-frequency artifacts, and EfficientNet B0 extracts high-level sentiments. These artifacts or features get stored in vector format. That these get combined through attention-based fusion with adaptive weights. Then final confidence C will be generated. Fourth layer is concurrency and threat management. In live detection, many processes are going simultaneously. So we are using asynchronous processes also, and we are also using frame drop policy here. It drops previous frames if system get overloaded, and works on current frame to update the UI and to keep video call smooth. And last layer is signaling and visualization. Here uh, we get we uh, we can see bounding boxes around our face, display confidence, and update color coding safe uh, color coded safety. Like if confidence is between 0 to 0.5, then it's authentic. It's between 0.5 to 0.7, then it's suspicious, and it's between 7 to 1, then it is deepfake. This allowed achieved in 25 to 30 frame per second under normal condition. Next slide shows a hybrid model architecture. It received pre-processed frames like 224 by 224 frames as a input. First branch is MobileNet V3. It uh, processed depth-wise convolution. It is lightweight and specially designed for mobiles. Its output is stored in vector, and here we are indicating it as a D1. And second branch is EfficientNet B0, uses compound scaling to balance depth, width, and resolution. It is stored as a D2. If accuracy matters, then weight give to EfficientNet B0, and if time permits, then it gives weights to MobileNet V3. Both D1 and D2 go through attention-based fusion models. This fusion representation then go to fully connected classifications. These are the results. We evaluated our model using a balanced dataset as face forensic plus plus celeb df and also our own dataset. The proposed hybrid model achieved 93.98 accuracy with f1 score of 95.71, outperforming both model uh, MobileNet V3 and EfficientNet B0 individually. These results demonstrate that attention-based feature fusion effectively combines the strengths of both lightweight architecture. The proposed hybrid model consistently outperformed both individual backbones, demonstrating that combining complementary feature representation improves detection performance. We also evaluated the framework on Snapdragon 778G Android device. The system achieved a total latency of 45.4 milliseconds, enabling 22 to 25 frames per second during live video communication. And after quantization, the model size we achieved model size up to 11.8 MB, providing nearly 1.9 9 times faster inference while maintaining average real-time detection accuracy up to 89.7. These results demonstrate the feasibility of practical on-device deployment. These results demonstrated that Veritas Face, that is our system, is not only accurate but also lightweight enough for practical deployment on Android devices. To conclude, we propose Veritas Face, a lightweight hybrid deepfake detection framework for secure mobile video communication. The proposed model achieved 93.98 detection accuracy while supporting real-time video communication, privacy preserving on-device inference at 22 to 25 FPS. Our work demonstrates that accurate and efficient deepfake detection is achievable on device, making it practical solution for future secure communications. These are references which we have used. Thank you.
Thank you so much. Do we have any questions? Okay. Sargun, you may complete your presentation. With that, we are done with our today's presentations. I would sincerely like to thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, would like to thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. And now, at last, I would also like to thank our session chair, Professor Disha S. Wankade, for chairing this session. This is a token of appreciation to the chair on behalf of the team of ICT4SD 2026 and Global Knowledge Research Foundation and partners. Thank you so much, ma'am, for your valuable presence. Please share some kind words with us for today. Okay, I would like everyone to switch on their cameras for a quick digital snapshot to capture this virtual discussion. Thank you so much, everyone. Stay safe and take care.